Hey guys, it's Miss Bonstock here doing your notes today on dilations. Just as a quick reminder and visual, you guys know I love pictures. A dilation is to make an object either larger or smaller. In most cases, we will be making the items larger, but some of the times, and they're more tricky, we're going to actually shrink the object. So let's go and get started. If you have a foldable version, this is just a visual of what that foldable looks like for you guys who like to print them. All right, so for our very first example, if we read over the vocabulary, there are a few things we need to talk about. So vertices are points. So find the points of the image. And if you remember, image is the new one. Pre-image is the old one. And it says after a dilation by a scale factor of 2. Now, scale factor of 2 means we're taking the item and we're actually going to make it 2 times the size. So in your brain, you should say, okay, well, that means it's going to get bigger. It's going to get twice as big. So anytime you see the word scale factor, I want you guys to remember that that just means to multiply. So we're going to be multiplying this item by, in this case, 2. But there is a few things we need to set up first. So because it said to find the new points of the new image, let's go ahead and set up our points bracket. So we know we're going to have pre-image, which is our old one, and then image, which is our new one. And then we're going to have A and its brackets. And then for the new image, if you guys remember, we call that A with a tick mark, which is A prime. And then I want you guys to continue to set this up for B and C. All right, so now that I have everything set up, we're going to go ahead and list our pre-image points, which are right here on the graph. We just need to count. Now, one thing that might be a little confusing to some of you guys is that you only see one quadrant. So if you need to kind of extend these lines over here to know that there are 4 quadrants, so this would be quadrant 1 where everything's positive. So A, and right here, this is our center. That's going to be our origin. So over 2, up 1. So that's going to be 2, 1. And then B is back to the origin, 1, 2, 3, 4, and then up 1, 2, 3, 4, 5, 6 till I got to the point. So 4, 6. And then C. So go back to the origin, 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4. So the opposite, 6, 4. All right, so we need to, like I said, make this twice as big because the scale factor is 2. So I'm just going to take all of these numbers and the points and multiply them by 2. So I'm going to start with A, and I'm going to change colors so I can plot the new image in a new color. So everything in A times 2. So 2 times 2 is 4, 1 times 2 is 2. Now go to B. 2 times 4 is 8, and then 12, and then 12, and then 8 for C. So then after you have the new image points, you can go and plot them on your grid. Make sure to use your little tick marks, your prime marks. All right, so I've got my new points, plotted. And I'm going to get my line tool so that I know it's nice and straight. And I'm going to go ahead and connect all of these. And again, we want to make sure that we did it correctly. So it shouldn't look like that it slid or rotated or reflected. It should literally just look like it got larger. And I definitely think it did. So if you are ready to move on, let's move on together. We're going to do example 2 together. So example 2 is very similar. We're going to find the vertices, which we said was points of the image. And this time it's a quadrilateral, so we will have 4 points to do, but not a big deal. And it is a scale factor of 3. So again, scale factor means to multiply. I'm going to write that out. And we are going to multiply this time by 3. So a scale factor of 3. So let's go ahead and set up again our pre-image and then image. And then this time underneath, make sure you go ahead and list out 4 points. So one for A, B, C, D, and then A prime, B prime, C prime, and D prime. All right, so this is what you should have your setup to look like. I'm going to go ahead and list the pre-image points. And we're going to start again right here from this corner, which would be the origin, and up 1 over 1 for A. And then B, back to the origin, up 1, and then up over 1, and then up 1, 2, 3, 4. So 1, 4. And then C, again at the origin, 1, 2, 3, 4, and then up 1, 2, 3, 4. So 4, 4. And then last but not least is D. So back to the origin, 1, 2, 3, 4, but then up only 1. All right. So again, we were going to multiply these points by a scale factor of 3. So all of these points listed need to be multiplied by 3. So I'm going to go ahead and do that. All right, so I have all my primes listed by taking every single one of these points and multiplying them by 3. So now I'm going to go ahead and find where those would be located on the graph and plot them. All right, so I have them all plotted. Of course, pause if you need to check yours. But I'm going to go ahead and connect those points with my line tool so it is nice and straight, and check it. Check to make sure that it looks like it got larger. And this one definitely looks like it got larger. And it did get 3 times larger. Something I want to point out is that you can definitely count the sides. We don't want to count the area or the squares on the inside, but you can count the side lengths. So this side length right here goes up 3 spaces, and that's AB. So I'm going to go to A prime, B prime, which are the same line, and I'm going to count. Let's go ahead and mark this as 3. And let's count this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that look 3 times bigger? It is. 3 times 3 would give you 9. And you could even check both of the sides that are proportional to each other. So AD, count with A prime, D prime. And then DC, count D prime, C prime. All right, so we are going to move on to example number 3. So for example number 3, this one is just a little bit trickier for several different reasons. For the first reason, you have a shape that is tilted. And some of the times when those shapes are tilted, it is hard to make sure that you're in the right spot you need to be when you're graphing the points. And then the scale factor on this one looks different as well. So something that it does want us to do that's exactly the same is to find the vertices, which are those points of the image. Remember, image is the new one. And it says that the dilation is a scale factor of, and we have not seen this before, a scale factor of 1/2. Well, we said that every time we saw the word scale factor, we were going to do what? Hopefully you said multiply. So we are supposed to multiply. But this time you are multiplying by 1/2. So something that I would recommend, if you know you're not good with fractions, is you might want to go ahead and pull out your Desmos calculator. If you are good with some fractions, like 1/2, you know that multiplying by 1/2 is really just the same thing as dividing by 2. So again, for this one, you can just cut them in half by dividing by 2, but I would like to maybe stick to practicing multiplication. So again, you can always stop right now and get your Desmos. Okay, so I went ahead and set mine up. If you need to do that and pause the video, go ahead and do that. But I'm going to go ahead and start writing in my points. So this is my origin, and I'm going further this time, so be very careful. 1, 2, 3, 4, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4, 10. And then B, again, go back to the origin. 1, 2, 3, 4, 5, 6, 7, 8, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 8, I believe I said, and then 12. And then go back to my origin for C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. So 12. 4. And then last is D. 1, 2, 3, 4, 5, 6, 7, 8, and then 2. All right, so now that we have those original, or what we call pre-image points, we can go ahead and do our image. Now we said that we're going to be multiplying, and we're going to be multiplying by 1/2. So I went ahead and grabbed my Desmos calculator because I want you guys to see that it is the same as division. So if I have the number 4 and I times it by 1 and then half, I get the answer 2. And then I'm going to do the next number, 10. So 10, and that is times, 10, and then we're multiplying by 1/2. And again, I got 5. So yes, you can go through it and divide them all by 2, but multiplying is what we really need to be practicing here. So multiplying by 1/2 is what I wanted to show you. So go through and multiply by 1/2 on all of yours. I'm going to do the same to mine. All right, so I have all my new points, all of the primes. They've all been multiplied by half, or cut in half, or divided by 2, however your mind thought of it. There's many different ways. And now you need to go ahead and graph all of the points for all of the new primes. All right, so I'm getting my line tool ready. I've got my points for my new primes marked. You, of course, can go ahead and pause that if you need to. But what I want you guys to look at is this time our image did not get larger. And if you look at the points, the numbers didn't get larger either. So that should have been a direct indication that, oh, if my numbers didn't get bigger, then my shape is definitely not going to get bigger. It got smaller. So this is one of those instances where instead of enlarging our figure, we are actually reducing it or shrinking it. So make sure you have all of those labeled and pause again if you need to. Otherwise, we are going to move on to our last example, which is example 4. Now, something I want you to notice about this one, it's a little bit easier because it's a triangle, but again, we have a scale factor that's a fraction. But I'll, say it till I'm blue in the face. Anytime we see scale factor, that is multiplication. So let's go ahead and write ourselves the note that says multiplication. This time, again, we are multiplying with a fraction. So if you were to take a guess based off of what happened last time, what would you say is going to happen to your scale factor, your actual item? What does that scale factor mean to you this time? And if you said it's going to shrink, I would agree with you because this is another fraction. And even though we're still multiplying, that fraction is actually going to make this item smaller. So let's go ahead and set up our image and our pre-image points. All right, so I've got my image and pre-image brackets set up. I'm going to go ahead and figure out what A is. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So 6 and 6 on that one, very easy. And then B, back at the origin, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 and 9. And then C is last. So back at the origin, and 12, 6. So this time it's 12 and 6. All right, so we are going to multiply, and we're going to take these items, let me clear it all out, and we're going to multiply it by a third. So 6 is our first point, times, and then 1/3, and it already tells me it is 2. So I know that first one's going to be 2, and that other 6, again, is going to be 2. So let's do our next one. All right, so I've got 9, and then times 1/3, and it's 3. So it'll be 3 and 3. Does anyone see what's happening when you're multiplying by a third? So if you said you're dividing by 3, it's correct because 6 divided by 3 is 2, 3 divided by 3 is 3. But I just kind of want to get us into the habit of multiplying because these fractions are not always going to be easy fractions like these. Sometimes they're messy, ugly ones. But even with messy, ugly fractions, if you multiply, you'll always get the answer. All right, so let me go ahead and set all of these up for us. Here are our new prime, A prime, B prime, C prime image points, and then we need to go ahead and graph them. So as you can tell, this really shrunk. I'm going to use the line tool real quickly to connect these teeny tiny points. But if you did this correctly, you would notice that, okay, my numbers got smaller, so my triangle got smaller. My scale factor was a fraction, so again, I know that my image should have been smaller. And it may be helpful to go ahead and make yourself, let me add a page here, you guys, just to kind of like type out something that would help ourselves. So if the scale factor is a whole number, what happened if the scale factor was a whole number? Anybody remember? The shape got bigger. I'm going to shrink that down so it's all on the same line for you guys. Easier to see. And then the next one, if the scale factor is a fraction, the shape gets smaller. And let's make that look the same. Gets bigger, gets smaller. And then what's another name for bigger? Enlarge. Need to make sure that we're sounding very 8th grade about this. And then to get smaller would be to reduce. All right, so just a little extra note to help you guys. Also make sure you're always multiplying. It's kind of the easy trick that just kind of keeps everybody on the same page. Rewatch, pause as you go, rewind if you need to, but I hope to see you guys in our Zoom session soon.